We are gonna solve this problem. At first, I tell you the identities you need, then we solve this. If you know basic identities, you can use my time codes and go straight forward to the solution part. So let's start. The first identity we want to consider is what? 1 over 3 plus 1 over 3 squared plus 1 over 3 cubed and so on. It is what? The second identity is x plus y squared equal to x squared plus 2xy plus y squared. And the third identity is x. We will prove these three identities. We will prove it is 1/2. And the last one, x plus y cubed, is x cubed plus 3x squared y plus 3xy squared plus y cubed. Before proving these three identities, thanks for subscribing, turning on notification, and like my videos. And in each topic like geometry, algebra, number theory, combinatorics, there are around 50 important ideas, especially in geometry, 50 important formulas if you want to learn them and are useful from qualifying level round 1 up to international level IMO. If you want to learn them, feel free to send message to my WhatsApp number in the description. Okay, so let's prove at first identity number 1. Let me write the proof with black. Proof of 1. So I call A0 1 over 3, 1 over 3 squared, 1 over 3 cubed, and so on. Then I say what? I multiply A0 by 3. It will be 3A0 equal to 1 plus 1 over 3, 3 times this. 3 times this will be 1 over 3 squared, and so on. If you pay attention, you will see, okay, here is exactly A0. So it has also another solution or another proofs. We want to use this one, the most basic one. So 3A0 equal to 1 plus A0. If you subtract A0 from both sides, 2A0 equal to 1 and A0 equal to 1/2. Now let's prove second identity. 2x plus y squared equal to x plus y times x plus y. And it will be what? X times x squared, x times y xy, y times x yx, and y times y squared. Because it is product xy equal to yx, the order is not important, so you can say it will be 2xy plus y squared, and we proved here x squared plus this. Now we want to prove third identity. Proof of third identity, x plus y cubed. You can say, you can do this, or there are also other ways. And for general n, you can use binomial theorem. But because we want to use only these two binomial theorems, I will prove them separately with basic methods. So it is xy squared. It will be x plus y squared. From second identity, I've reached it is x squared plus 2xy plus y squared. Then if I multiply x times this will be x cubed plus 2x squared y plus xy squared. Now let's multiply y. It will be y x squared plus 2xy squared plus y times y squared, which will be y cubed. Now if we calculate this, 2x squared y here, xy squared here, it will be x cubed plus one line 3x squared y, double lines, plus 3xy squared plus y cubed. So we proved this now. Let's solve the problem. Solution. The problem says what? Calculate 1 cubed over, problem says it is what? So I consider the degree, the power of the numerators here is 3, 3, 3. So I call this one A3. And I want to find A0, it will be what? Like the identity 1 to the power of 0, 1, 3 to the 1, 2 to the 0, it will be 1, 3 squared, 1, 3 cubed, 1 over 3 to the 4. From first identity, in the beginning of the video, I said it is 1/2. Now, a1 is what? Here, you say it is 1 to the power of 1. a1, I define it like this. The next one, 2 to the power of 1, 3 squared. The next one, 3 to the power of 1, 3 cubed. 4 to the power of 1, 3 to the 4, and so on. I want to calculate a1. I can write it like what? 1 over 3 to the 1 plus 1 over 3 squared plus 1 over 3 cubed plus 1 over 3 to the 4. We write this idea is useful. Now this one finished, it is 2 here. So you write again, start from here. 3 squared, 1 over 3 cubed, plus 1 over 3 to the 4, plus so on. So 2 here, it is okay. Now, for third one, you write again, you start from here, this part. Now we have 3 over 3 cubed, plus 1 over 3 to the 4, and so on. This one, 1 over 3, 4, so on, and this one, you write. From first identity, you use a0. It is a0. It is what? It is a0 over 3. Because look, if we divide this by 3, it will change to this, change to this, change to this. The next one. a0 over what? 3 squared. This one. a0 over 3 cubed. Because look, a0 is this. If you divide by 3 cubed, it will be this. Now, a1 will be what? a1 here will be a0 plus a0 over 3 plus a0 over 3 squared plus a0 over 3 cubed, and so on. So here I say what? The first a0, I say it is 1/2 from first identity we've reached in the beginning of the video. Then I factor from the rest of the terms from a0. It will be 1 over 3 plus 1 over 3 squared plus 1 over 3 cubed, and so on. So this part will be what again? a0, because the definition of a0 was this. Again, we apply first identity. a0 is 1/2, so it will be 1/2 times 1/2. So it will be 1/2 plus 1 over 4. If we use common denominator 4, it will be 2 here plus 1, which equal to 3 over 4. So we found a0, a1. Now we want to find a2, and then we find a3, which is the problem. a2 will be what? Will be 1 squared over 3 to the 1 plus 2 squared over 3 to the 2 plus 3 squared over 3 cubed plus 4 squared over 3 to the 4, and so on. So I want to do what? I say if I divide this by 3, a2 over 3, it will be what? 1 squared over 3 squared. This will change to this if you divide by 3. And then the next one, 2 squared over 3 cubed. The next one, 3 squared over 3 to the 4. And then, if we subtract this minus this, a2 minus a2 over 3, it will be what? 1 squared over 3 to the 1 plus 3 squared is what? 2 squared minus 1 squared plus the next one, 3 squared minus 2 squared over 3 cubed plus the next one, 4 squared minus 3 squared over what? 3 to the 4, and so on. So for finding this, I should see that this minus this is what? It is x plus 1 squared minus x squared. By second identity in the beginning of the video, it will be what? X squared plus 2 times 1 times x. 2x plus 1 squared, which is 1, minus x squared. So we cancel these two things and it will be 2x plus 1. So if we check this part, let me move it here. We want to use this part. Let's check it. The first one is 1 squared over, let's write 1 over 3. And the next one, x is what? X is 1. 1 plus 1, 2 squared minus this. So by these things, it should be 2 times 1 plus 1, 3. Let's check. 4 minus 1 is 3. Yes, it is 2 times 1 plus 1 over 3 squared. The next one, 9, it is 3. X is what here? X is 2. 2 plus 1, 3 squared minus 2 squared is 2 times 2 plus 1, 5. 9 minus 4, 5. Yes, so it will be 2 times 2, x is 2 plus 1 over 3 cubed. So you guess the next one is what? 2 times 3 plus 1 over 3 to the 4. And so on. So let's calculate the rest. Now here I want to divide to two parts. 1 over 3, this one, all of them 1. I write them in red. It will be 1 plus 0, 1 3 squared, 1 over 3 cubed plus 1 over 3 to the 4, and so on. And then I write the rest with green. This part, this part, this part. And I factor from 2. It will be 1 over 3 squared plus 2 over 3 cubed plus 3 over 3 to the 4, and so on. So we want to see each part is what. So here I will understand the red part is what? The red part is exactly A0 by the definition. But the green part is what? We know for green part, A2 was what? Or A1, sorry. A1 is what? 1 over 3 to the 1 plus 2 over 3 squared plus 3 over 3 cubed plus 4 over 3 to the 4. So what's the relationship? It is 2 times. The thing inside this part, the relationship, it is exactly A1 over 3. So you can divide it by 3. This part by 3, it will be 1 over 3 squared, 2 over 3 cubed. It will be 2A1 over 3. So now you can calculate this. A0, let me erase it. A0 is what? Is 1 half plus 2 over 3 A1. A1 was what? We've calculated A1 here is 3 over 4. So it will be times 3 over 4. 3 will be cancelled. 2 here, 2. So it will be 1 half plus 1 half. Equal to what? Equal to 1. But it was what? It was A2 minus A2 over 3. A2 minus A2 over 3 equal to 1. So if you use common denominator on left hand side, it will be 3. 3A2 minus A2 equal to 1. So 3A2 minus A2, 2A2 over 3 is 1. You multiply it by 3. 2A2 equal to 3. And then you divide by 2 both sides. You divide by 2. It will be 3 over 2. So we found A2. And the last part is how to find A3. So let's calculate A3. It will be 1. We use the same idea. 1 cubed over 3 to the 1 plus 2 cubed over 3 squared plus 3 cubed over 3 to the 3, 3 cubed plus 4 cubed over 3 to the 4, and so on. Again, by similar way, we divide by 3. It will be what? This part will be 1 cubed over 3 squared. The next one, 2 cubed over 3 cubed plus this one, 3 cubed over 3 to the 4, and so on. So here, if we subtract first one minus second one, it will be what? A3 minus A3 over 3. It will be what? The first one, 1 cubed, or you can say 1. 1 over 3 to the 1. The next one, both denominators are 3 squared. So we write 2 cubed minus y cubed, 3 squared. The next one, 3 cubed minus 2 cubed, 3 cubed. Now, the next term is 4 cubed minus 3 cubed over 3 to the 4, and so on. Now we want to use third identity. We said what? Here it is x plus 1 cubed minus x cubed. If we use third identity, I told you in the beginning of the video and we proved it will be x cubed plus 3x squared times 1, x squared, plus 3x 1 squared, 3x plus 1 cubed, which will be 1 minus x cubed. You cancel these two things and it will be 3x squared plus 3x plus 1. So let's check. It will be 1 over 3 to the 1 here. X is 1. If you check, it will be what? 2 cubed minus 1 cubed, 7. If you replace x with 1, 3, 1 squared plus 3 times 1 plus 1, 7. So here it will be 3 times 1 squared plus 3 times 1 plus 1 over 3 squared plus this one. 27 minus 8 is 19. If you replace here, look, 3x plus 1, x is 2. If you replace 3 times 2 squared, 4, 3 times 4, 12, plus 3 times 2, 6, plus 1, 19. So we can write the next one, 3 times 2 squared, plus 3 times 2, plus 1 over, all over 3 cubed, and so on. Now, I consider this one, all these ones with red, and this one with green, and the next one with pink. 3 1 squared, 3 2 squared, and so on with pink. So let's calculate these terms. At first, red 1. 1 over 3 to the 1. 1 over 3 squared. 1 over 3 cubed. It was red. Now, let's calculate green. It is what? We factor from 3 here. 3, 1 over 3 squared. Here, 2 over 3 cubed. And you can write also, next term will be 3 over 3 to the 4, and so on. Now, let's write the pink one. Again, we factor from 3. It will be 1 squared over 3 squared, 2 squared over 3 cubed. The next one will be 3 squared over 3 to the 4, and so on. Now, let's calculate each term. The first one, the red one, is what? Is exactly A0. The green one is what? I know A1 is what? A1 is 1 over 3 to the 1 plus 2 over 3 squared plus 3 over 3 cubed, and so on. So if you pay attention, it is exactly A1 over 3. So this part, we have 3, and inside this part, it will be A1 over 3 by this definition, this part. Now, the pink one is related to A2. We know A2 is 1 squared over 3 to the 1, 2 squared over 3 to the 2, plus 3 squared over 3 cubed, and so on. So here, you factor from 3, and inside this part, it is the relationship to A2, it is exactly A2 over 3. Okay, so if you write all of them, A3 minus A3 over 3 here will be what? Will be A0 plus A1 plus A2. We found that A0 is 1 over 2, A1 is 3 over 4, we proved. Let me show you here. A1 is 3 over 4, and A2 here, we've calculated A2 is 3 over 2. So it will be 1/2 plus 3 over 4 plus 3 over 2. So here, let's calculate. If we multiply both sides by, let's see, 3, let's calculate this at first. We factor from 4, it will be 2 plus 3 plus 3 times 2, 6. 6 plus 2, 8. 8 plus 13 plus 3, 11 over 4. Let's multiply by 12. So it will be 12A3 minus 4A3 equal to 33, because 12 times this by 4, 3 will be left, 3 times 11, 33. So it will be 8A3 equal to 33, and we can conclude if we divide both sides by 8, A3 equal to 33 over 8. Okay, so if you had any question about the solution of this problem or wanted to learn the other ideas of algebra, geometry, number theory, combinatorics, and other topics, feel free to send message to my WhatsApp number in the description. Also, thanks for subscribing, turning on notification, like my videos. You can use my other playlist like Harvard, Stanford, MIT Math Tournament, SMT, HMMT, also USA, AMC, American Mathematical Olympiad or mathematics competitions, BMO for British. You can use those playlists to improve your problem solving. Thanks for watching this video.